Assalamualaikum and good day. Today I would like to present my project analysis on small-scale incinerator. My name is Akmal and my supervisor is Dr. Nur Hazwani binti Mokhtar. 10 years ago, there were 2.9 billion urban residents who produced 0.64 kg of municipal solid waste per person every day. Now, today, population already increased to 3 billion people that produce 1.2 kg of waste for each person per day. By 2025, the population continued increase to 4.3 billion that generate 1.42 kg of municipal waste per person for every day. In South Asia, each year they generate 70 million tons of waste. With 1% produced waste in range 0.12 kg to 5.1 kg each day, with average 0.45 kg per capita per day. To dispose the waste, there are many ways, for example, open burning, recycling, material recovery, incineration, and landfill. All of these ways have their pros and cons, which pollute the environment except recycling and material recovery. Solid waste Malaysia. Solid waste management in Malaysia become difficult to deal because the population increase every year. So it affects the generation of solid waste in our country. Malaysia average generation of solid waste per capita is currently 1.17 kg per day. In Malaysia, landfills is the primary method to dispose the waste because it is easy to operate, require less technology and technical feasibility. Issue number 1. Several landfills already reached their maximum faster than estimated their lifetime as a result from fast-paced urbanization and population growth. For issue number 2, incineration is either one of disposal method, but the cost of operating is very high because its installation is expensive process and it requires high-trained workers. Service for solid waste collection are only offered in metropolitan areas, while residents on rural regions dispose the solid waste with bury or open burning, which contribute to illegal dumping. So, this proposed analysis on small-scale incinerator that is suitable for home use. Objective number 1 for this project is to design the small-scale incinerator in SolidWorks software. Objective number 2, to perform the simulation of the small-scale incinerator in SolidWorks software. Objective number 3, to analyze and validate the simulation analysis data. Scope number 1 for this project is type of incinerator is small-scale incinerator for household use. Scope number 2, type of material used for the drum of incinerator 1023 carbon steel sheet, which is used in market. Scope number 3, parameter of drum. The drum thickness is 6.9 mm. Then in this analysis, there are 3 designs of drum. Design A 100 liter, Design B 150 liter, Design C 200 liter. Scope number 4, range volume flow rate of air. There are 3 different volume flow rate used: 1.19 meter cube per minute, 5 meter cube per minute, and 10 meter cube per minute. Scope number 5, range of temperature. There are also 3 different temperatures used in this analysis: 26.6 degrees Celsius, 500 degrees Celsius, and 1300 degrees Celsius. Scope number 6, simulation is use SolidWorks software. And scope number 7, type of analysis. There are 2 types of analysis in this project: flow analysis and structure analysis. Author from Kamarudin in 2017, it tells about generation solid waste in Malaysia and relationship among urbanization, waste generation, and availability landfills. Second is from Ismail in 2013. It says the challenge process landfill in Malaysia with limited space available in this country and concern about environment effect from landfill. Next is from Moh and Abdul Manaf in 2017, it talked about solid waste management and disposal method in Malaysia, also number of landfill and incinerator in our country. This is methodology process flowchart. It starts with design survey question in Google Form, which we want to know some detail from respondent and their knowledge about the incinerator. Then survey distribute through social media, data collect from the survey. Next is design small-scale incinerator in SolidWorks software. Then run simulation, collect data and obtain analysis. To achieve objective number 1, we refer to literature review and distribute survey question to respondent. Then design the small-scale incinerator in SolidWorks. Then to perform the simulation, we use flow and static simulation by using SolidWorks software. In flow simulation, there are two parts, flow trajectories and cut plot. Static simulation also have two parts, which is maximum pressure test and temperature set to 800 degrees Celsius and 1300 degrees Celsius. And lastly, we do flow and structure analysis from simulation data. For flow analysis, flow data were analyzed in two sections, flow trajectories and cut plot. Flow trajectories used to analyze the airflow in the drum. Cut plot used to analyze control in the drum. As you can see, this is the boundary condition for flow analysis. The fluid type used in this study is air. Next, there are three different simulation temperature. Temperature 1 is ambient or room temperature, which is 26.6 degrees Celsius. Temperature 2, 800 degrees Celsius. And temperature 3, 1300 degrees Celsius. For volume flow rate, we have three values. Volume flow rate 1 is 1.19 meter cube per minute. Volume flow rate 2 is 5 meter cube per minute. And volume flow rate 3 is 10 meter cube per minute. This is the flow trajectories for design A. The different value, flow rate and temperature are tested on each design. From the table, the change of temperature and volume flow rate does affect the air velocity. Same goes to design B. The value of velocity affected by the change of temperature and volume flow rate. And lastly, in design C, the pattern of the airflow is same as design A and B. The difference of temperature and volume flow rate does not affect the pattern of the airflow entering the drum. And this is the cut plot section. All of the design were exposed with different volume flow rate and temperature. The data shows value volume flow rate influence the temperature H inside the drum. When the volume flow rate used is 10 meter cube per minute, the temperature at the bottom of the drum is low compared to volume flow rate used 1.19 meter cube per minute. Based on all the temperature pattern, design B shows that all value volume flow rate tested on it does not affect the temperature level very much in it compared to design A and design C. Structure analysis. Structure data were analyzed in two sections, maximum pressure and set of temperature, 800 degrees Celsius and 1300 degrees Celsius. From the figure, there is boundary condition for structure analysis. Maximum pressure. All of the drum design was tested to find the maximum pressure that the drum could withstand before deformation. From the data, design A has the highest maximum pressure value, and design C has the lowest maximum pressure value. From the simulation, all of the drum design show deformation with different deformation scale. This is the condition of the drum after exposed with temperature 800 degrees Celsius. And this is the design of condition of drum tested with temperature 1300 degrees Celsius. The data shows maximum pressure obtained from each design exposed with temperature 800 degrees Celsius and 1300 degrees Celsius. Each design's maximum pressure data is affected by the temperature value. According to the data, All of the designs in different volumes do not deform after being exposed to temperature of 800 degrees Celsius and 1300 degrees Celsius, so that all of the design small-scale incinerators are safely to use within range temperature 800 degrees Celsius to 1300 degrees Celsius. In practice, there are many ways that the analysis of small-scale incinerators process can be improved, depending on the design and the way to burn the solid waste. This thesis presents a method for analyzing the flow and structural analysis of the small-scale incinerator by SolidWorks simulation. The main feature of the analysis is that it establishes a simple and effective simulation of all of the designs. Overall, the research presented in this thesis has succeeded in making analysis to developing the prototype of the small-scale incinerator. For recommendation, the first is create a better design for the small-scale incinerator for easy use. Second, develop a system to facilitate users dispose the solid waste, like portable incinerator that can easily move. The third is include research to establish a better flow rate, the air entering the incinerator. And lastly, develop a better system for the small-scale incinerator to operate the disposal process. For example, incinerator have switch to start the fire.